Okay, so as we begin this next very, very short unit, I just want to go back to what we've discussed before. When we have discussed univariate data, we've usually been just talking about one variable. So referring back to our restaurant menu task, you were looking for one nutritional value. Okay, so we're going to talk about, with bivariate data, we're going to talk about two. So if we were talking about the same task, we would be comparing maybe the sodium as well as the protein. And like what happens as the sodium increases? Does the protein also increase? So that's going to be the difference between what we did before and what we're doing now, between univariate data and bivariate data. So this next unit is only going to be a couple of lessons, and it's going to be very short and pretty simple. It's just going to be more so how you analyze the data. So the first thing that we're going to talk about is scatter plots and trend lines. So if you've ever seen a scatter plot, it just kind of looks like the first quadrant of an XY, of a coordinate plane. And we're going to be looking at something called the correlation. Oh, don't want to move that. The correlation. Okay, and the correlation, it's just like it sounds, or like you've used it in real world terms. It describes a relationship between two things. So if we're talking about, like I'm on an XY coordinate plane, we're talking about the correlation between, I don't know, you could say time and let's just say the amount of time that you study and your grades. Okay, so as the amount of time increases that you spend working on your studies, your grades is going to increase. Okay, so that right there is a correlation. And it can also be, so that would be a positive correlation. You could also see a negative correlation, where the amount of time that you spend playing video games maybe decreases your grades. Okay, so that could be a negative correlation. Or you can have no correlation at all. We could say that these actually don't have anything to do with each other, and that would be just no correlation. Okay, so it would look like that. But in order to determine the correlation, you can use this sentence model. So you can say, as the X variable increases, then the what does the Y variable do? And then that'll help you determine your correlation. So in this instance here, to this picture that I've drawn, our X variable is our time, okay? And our Y variable is our grades. So as our time increases, our grade increases or decreases. So this is the model that you would use here. Okay, so then you're going to determine the type of correlation that it is. So if Y is increasing as X is increasing, okay, it's going to be a positive correlation. If X is decreasing if Y is decreasing as X is decreasing, then the correlation is negative. And then if you show absolutely no pattern, then it's just no correlation. So for this example here, we're going to determine the correlation between the amount of time a block of ice sits at room temperature and the amount of ice that remains. So our X variable here is going to be the amount of time that the block of ice sits at room temperature. Okay, so time is our X variable. And as it increases, the amount of ice remaining is actually going to decrease. Okay, because we know that when ice sits for a long period of time at room temperature, it's going to melt. So the ice that's remaining is decreasing. Okay, so what does this look like? Okay, so on a graph, it's going to look like the amount of time that it's sitting at room temperature is increasing, time is passing, okay, but the amount of ice still there is going to decrease. So this is going to be a negative correlation. Okay. It can also be displayed by a graph. Now, a positive correlation looks like this. A negative correlation, and then no correlation kind of looks like this. There's really not a way that you can put that in. And a way that we can describe this is by it being a strong or a weak correlation, and it can be determined by a number. And we call that number the correlation coefficient. And it can be estimated based on the direction and how strong or weak the correlation is. So a positive 1 correlation, the closer to 1 is going to be the stronger correlation. So a positive 1 would be a strong positive correlation, because again, it's a positive 1. Now a negative 1 would mean that it's a strong negative correlation. Now, if it was not strong, it would be a positive maybe 0.5, or a strong negative would be negative 0.5. Okay, notice how those are close to 1, but they're not 1. And then a 0 would be no correlation. Okay. So for the next example that you have on this page, you're given 3 graphs, and I want you to try and determine, is it a strong positive, a strong negative, a weak positive, weak negative, or no correlation? And those numbers, the correlation coefficient, would to describe that. Okay, so this sums up this lesson for today. Again, it's all about just the correlation between an x and y value, which is something that you've probably already described, and the correlation coefficient, okay? And remember the positive correlation going in one direction, the negative going in another direction, and no correlation in another. All right.